What does it mean for a graph to be symmetric with respect to the x-axis, the y-axis, or the origin? It just means that it's symmetric with respect to the x-axis. So every point on one side, if you flip it over the x-axis, it's going to be on the other side. More technically, you can look at the descriptions. I want to get into the y-axis and the origin. When you have symmetry with respect to the y-axis, that graph is also called an even graph. And even graph means, by definition, and you should know this definition, is that f of negative x is actually going to equal your f of x. And in an odd function, what that's going to mean is that a negative f of x is equal to f of negative x. Now, that seems really confusing, and that's why it's really important for you to always go back to the definition to determine if it's even or odd. Now, all even functions reflect over the y-axis, and all odd functions reflect about the symmetry, about the origin. So when I do some examples, you're going to see that the first thing that I want to do is to determine if they're even, odd, or neither algebraically. And then what I'm going to do is actually graph them and show that it's true. If you look at f of x, what I want to evaluate is the f of negative x and see if this expression is the same as the one up above it. They are not equal, and if I did negative f of x, those are not equal as well. None of the three are equal, so the answer to this is that they are going to be neither. If you go to number 2, you're going to see when you put in negative x is the same thing as putting in x to the fourth, and if you put in negative x to the x here, you're going to get the same thing, and so therefore these two are exactly the same. Means g of x equals g of negative x. By definition, that means that it's an even function and it's symmetric over the y-axis. If you look at this one, number 4, you're going to see that, again, I'm going to try to find out what is g of negative x, and by putting in negative x for x, I get negative x cubed, and you get a positive 6x as you distribute that negative out. And you're going to see that if you put a negative x on the left side, if you multiply negative 1 to the left side and negative 1 to the right side, you are going to actually get that negative g of x. You're multiplying both sides by negative 1. And when you do that, you're going to see these two are actually equal, which means that g of negative x equals negative g of x. Odd function, it's reflective about the origin. I want to graph a couple of these just to verify that it's true. By looking at a graphing calculator, I'm going to go to number 2, and I set the window correctly, so it should have a decent graph. And when I go and graph this, not the best graph, but you can see that it is reflective over the y-axis, which means that this is going to be an even function. And if I looked at number 4, I'm going to see that it should be an odd function, which means it should be symmetric about the origin. When I graph that, you will see that every xy is going to have a negative x, negative y on that graph. And the reason why I knew that is because I algebraically plugged in negative x and found out that my g of negative x is equal to a negative g of x. That should summarize symmetry with respect to the x-axis, the y-axis, about the origin, as well as how to confirm it algebraically. And at the same time, it ties in the even and odd functions.